Talking about end behaviors. Our essential question is, what are end behaviors? How do we write them? And how can we predict them without graphing? So the first thing we start with is end behaviors of a graph. What are the two ends of the graph doing? That is exactly what we want to know. So look at the two ends of the graph. Where are they going? That's what you're trying to answer. How do we write them? Well, we have the left end behavior. As x approaches negative infinity, what is y doing? Right end behavior. As x approaches infinity, what is y doing? Okay, so go ahead and pause and write this stuff down, and then we'll take a look at a couple of problems. Okay, for example 1. First thing you need to do is you need to locate where your ends are. So take a moment, pause, and locate the ends of your graph. Okay, now that you've determined the ends of your graph, the next thing you're going to do is you are going to look at the left side of your graph and notice that x is approaching negative infinity when it's going to the left. So we're going to write down as x approaches negative infinity. This little arrow means the word approaches. So in mathematical terms, that's what that means. So I don't even have to write the word. So as x approaches negative infinity, what is y doing? Y is going up or down. If it's going up, it's approaching positive infinity. If it's going down, it's approaching negative infinity. So notice that this one is going up, so y will be approaching positive infinity. And that is our left end behavior. So this is for the left side. This is the end behavior for the left side. So now we need to do the one on the right side. The right side, we have the arrow coming down. Now when you're on the right side, x is approaching positive infinity. So when you go into the left, x is approaching negative infinity. When you go to the right, x approaches positive infinity. So what is y doing as x comes to the right? Well, you'll notice that this arrow is going down. So y is approaching negative infinity on this particular graph. And that is our right side end behavior. And they always come in pairs. You have two ends of a graph. You just locate them and you determine what that end is doing. So go ahead and pause and finish writing this down if you've not already. And we'll move on to the second example. Okay, for the next problem, you'll notice on the previous one we had arrows that were on the ends of it. On this one, we're going to have points on the ends of it, so you can see how it's a little bit different. First thing, I would like you to locate your ends of this particular graph. So go ahead and pause and locate the ends of this particular graph. Okay, you'll notice on this graph that our ends are located here and here. Even though they don't have arrows, they are still ends. So the next thing I need to do is figure out where those points are located. So on this particular graph, this point on the left side is located at -8 and 6. So this ordered pair is -8, 6. And over here on the right side, it's located at 10, 8. Now, if it's a point, you locate and figure out what that point is. If it's an arrow, then it's just approaching infinity or negative infinity. So on this particular graph, when I'm looking at the left end behavior, this is the left side, I'm going to figure out as x is getting close to -8, what is y approaching? Well, as x is getting close to -8, y is getting close to 6. So my end behavior on the left side is as x approaches -8, y approaches 6. Doing the same thing on the right side. This is my right side point. As x is approaching 10, y is approaching 8. So whatever the value of that ordered pair is, gives you your two values for your end behavior. Go ahead and pause and finish recording your answer.
Baby for